We're going to go over 7.5, so more trig functions or more trig equations. We're going to be solving trigonometric equations by using the identities. So here we have the unit circle on the right. This will be provided for your test. I'm going to write the identity. So the identity that we're going to be using for the most part is going to be sine squared plus cosine squared equals to 1. So they want us to solve this equation. We have 1 plus sine squared equals 2 cosine squared. I'm going to rewrite it. So what I'm going to first do is I'm going to take this cosine square and change it into 1 minus sine. So we're going to be left with, I'm going to rewrite the left side as 2 times 1 minus sine square of theta. Now I'm going to distribute the 2 to both terms. So I'm going to be left with 1 plus sine of theta equals 2 minus 2 sine square of theta. I will then go ahead and add the 2 sine squared on both sides. And I'm going to be left with 2 sine square of theta plus sine squared plus 1 is equal to 2. I'll subtract the 2. And I'm left with 2 sine square of theta plus sine theta minus 1 is equal to 0. Now, guys, we're going to use the substitution method. We're going to say that y is going to equal sine theta. So I'm going to go ahead and plug in 2y squared plus y minus 1 is equal to 0. And I'm able to factor this. We're going to look for the factors of negative 2 that add up to positive 1. So we're going to get negative 2 and positive 1. This is going to be 2y minus 1 and 2y plus 2 equal to 0. We're going to equal each parenthesis to 0. So I'm going to go ahead and do that here. 2y minus 1 is equal to 0. So we're going to add the 1 first. 2y is equal to 1. Y is equal to a half. And then we're going to equal the 2y plus 2 is equal to 0. We'll subtract the 2. 2y is equal to 2. Y is equal to negative 1. Now we figure out that our y is going to be a half and negative 1. Now let's look at the unit circle. Where is our sine? Or in this case, remember, sine is y over r. So we're going to look at the y value. When is our y a half? And when is our y negative 1? We have right here, here, and here. We have 3 places where our y is equal to a half, a positive half, and 1 place where our y is equal to negative 1. Therefore, your answer is going to be that angle. It's going to be the angle pi over 6, 5 pi over 6, and 3 pi over 2. This would be your final answer. Now they want us to solve this one for the interval 0 to 2 pi. So all that means is your final answer is going to be between 0 and 2 pi. Now, again, the trig identity, I'm going to write it up here just to have it. We have sine square of theta plus cosine square of theta is equal to 1. We have the identity cosine square plus 1 equals sine theta. So I'm just going to go ahead and write it. Now I'm going to go ahead and square it so I can do some substitution in it. We're going to FOIL the cosine square plus 1. And after we FOIL it, we're going to get cosine square of theta plus 2 cosine theta plus 1 is equal to sine theta squared. Now sine theta squared is going to be 1 minus cosine squared. I'm going to go ahead and rewrite the left side first. And I'm going to change the sine square into 1 minus cosine square of theta. I'm going to go ahead and combine the squares. So I'm going to go ahead and add the cosine square of theta on both sides. I'm going to be left with 2 cosine square of theta plus 2 cosine theta. I'm going to go ahead and also, in the same step, subtract the 1. They happen to cancel out, so we're left with that is equal to 0. Now I'm going to go ahead and change the cosines to x. Just a substitution to make it easier to solve. So we're going to have 2x squared plus 2x is equal to 0. Now I'm going to take out the greatest common factor of 2x. So this will be left with x plus 1 is equal to 0. I'm going to equal the 2x and the x plus 1 equal to 0. So it's going to be 2x is equal to 0. And x plus 1 is equal to 0. Divided by 2. And we get x is equal to 0. I'm going to subtract 1. And I get x is equal to -1. Now we're going to look at the unit circle and see where our x is equal to 0 and where our x is equal to -1. We have 1 right here, 1 right here, and 1 right here. So our final answer is going to be pi over 2, pi, and 3 pi over 2. Now I want you to notice for the previous problem I chose y for the sign because that is the value that I was looking for in the order pair. For this one, I chose x because x is the value that I'm looking for cosine. So if it makes it easier, always try and choose the the letter that corresponds to that trig function, x to cosine, y to sine. So we have equations with trigonometric functions of multiple angles. So now we're going to be finding other stuff other than just the x and the y on the axis. So here we have example 5. It says to consider the equation 2 sine 3 theta minus 1 is equal to 0. The first thing they want us to do is find all the solutions for the equation. So we're solving for what sine is going to be equal to. And they want us to find the solution in the interval of 0 to 2 pi. Now don't worry about this. This is just 0 to 2 pi is a full circle, which is the unit circle, which is what you're going to be finding every single time, which is going to be within the unit circle. So let's figure out how to solve this. We have 2 sine 3 theta minus 1 is equal to 0. I'm trying to solve for sines. The first thing I'm going to do is I'm just going to go ahead and add the 1, trying to get it by itself. We have 2 sine 3 theta equals 1. Then I'm going to go ahead and divide by 2. We have sine of 3 theta equals a half. Now, the only places where sine is equal to a half is right here and right here. I've circled them. It is 5 pi over 6 and pi over 6. But we have a 3 theta. So what we're going to do is we're going to substitute the sine. We're going to equal the 3 pi. Sorry, not 3 pi. The 3 theta is going to equal the 5 pi over 6. And it's going to equal, the 3 theta is going to equal the other option that we have, which is pi over 6. Now we're going to divide by 3. We're going to do keep, change, flip. I'm going to do this one up here. So we're left with theta is equal to 5 pi over 6 times a third. So we get the first theta to be 5 pi 18. And then we're going to do the same thing here. We're going to divide it by 3, which again is going to be keep, change, flip. And we're going to be left with theta is equal to pi over 18. So here we have two answers. So the key concept to find when it's stuff other than just sine theta, cosine theta, you have stuff with the theta, is solve it out until it's by itself. See what it equals. It's a half. We looked at the angles, pi over 6, 5 pi over 6. And then just equal the 3 theta equals to 5 pi over 6 and pi over 6. and just solve for it as if it were an x, and you will get your theta. Now for this problem, it says consider the equation the square root of 3 tangent theta over 2 minus 1 is equal to 0. They want us to find all the solutions to the equation. Again, it's always going to be within the circle, so we can just scratch the second part off. So I'm going to go ahead and rewrite the equation, the square root of 3 tangent theta over 2 minus 1 is equal to 0. Now I'm going to go ahead and do just like the other problem, solve for tangent. So I'm going to add 1. We're going to get root 3 tangent theta over 2 is equal to positive 1. I'm going to go ahead and divide by root 3. But remember, we're going to have to rationalize this. So I'm going to do root 3 on the top and then times root 3 on the bottom. We're going to get tangent theta over 2 is equal to root 3 over 3. Now I'm going to look where the tangent is going to be root 3 over 3. Remember, tangent is y over x. So we're going to look at the unit circle and do y over x for a few things. I'm going to do y over x for pi over 6. So if I do a half divided by root 3 over 2, that becomes keep, change, flip. These cancel. We're left with 1 over root 3, which after rationalize it, we get root 3 over 3. Therefore, it's going to be pi over 6. Yeah. And then I'm going to choose as well the 7 pi over 6 to try it out. So if I do negative a half divided by, so y over x, negative 3 over 2, that's going to become negative a half times negative root 3. Sorry, I didn't flip it. It's keep, change, flip. So it would be times negative 2 over root 3. The negatives cancel, so does a 2. And we're left with 1 over root 3, which rationalizes to root 3 over 3. So therefore, I have my two angles, 7 pi over 6 and pi over 6. Now, why did I choose those two quadrants and nothing else? Because we got a positive tangent. Remember, when we're doing the CAS or All Student Studies Calculus, the first quadrant, everything is positive, so that's why I choose the first quadrant. Then I chose the third quadrant because that is when tangent is positive as well. That's why I didn't bother with the second or the fourth to find out which tangent is positive with the root 3 over 3. Yeah. Now we have the angles that our tangent is positive at root 3 over 3. So we're going to do the same thing we did for the sine. Theta over 2 is going to equal pi over 6. And theta over 2 is going to equal 7 pi over 6. I'm going to go ahead and multiply times 2 to cancel it out. We're left with theta is equal to pi over 3. And here I'm going to multiply times 2 as well. And I'm left with theta is also equal to 7 pi over 3. This is it for today's notes, guys.